Hi everyone. This is lesson 7-3, finding the areas of trapezoids and kites. We'll talk about what those are in a second. If you want to follow along in your book, this is on page 300. Oops, try that again. It's on page 399, and then page 400 and 401 as well. So this problem says, if you look right here to the left, the European basketball key was changed from a trapezoid shape to a rectangle in 2010. The diagram shows the shape of the key before 2010 outlined in blue. So if you see outlined in blue, the key to a basketball court is where players stand for free throws. They stand around it. There's also other rules for the key, but usually the basket would be down at this area, down there. So that yellow area, let me see if I could make it a little different color. There we go. That green area or green shape is the key. So that's what the European basketball key used to look like. It was not a rectangle. As you can tell, that's not a rectangle. That is a trapezoid. What makes this a trapezoid and not a parallelogram is that this only has one set of parallel sides, one set of parallel lines. So there's the set of parallel sides. Parallel meaning, again, if they go on forever, if I were to bring it out, they would never cross each other. Okay? So those are the sets of parallel sides right there. So because this is not a parallelogram, I cannot use this area equals base times height. I can't use it. Here's why. I could tell the height is 5 8/10 meters because I see that dotted line going down, forms a nice 90-degree angle right there, and it would form a nice 90-degree angle up top as well. So that's the height. So, but what's the base? Is 6 the base? Or is 3 6/10 the base? Because if I did area equals base times height for each one of those, I would get two completely different answers. And every polygon can only have one area. It can't have two different areas. So we're going to go to back this problem in just a second. Let's take a look at a little bit easier of a problem and see if you can figure out how to find the area of a trapezoid. So let's look at example 1. And again, this is on page 400 in your book if you want to take a look at it. Okay, it says a trapezoid is a quadrilateral four-sided figure with only one pair of parallel sides. So over here on the left, we have a trapezoid. It looks like it is a horse pen. Why the pen is shaped like a trapezoid or a field, I have no idea why, but I guess horses like trapezoids. So if I look at this, again, I cannot use area equals base times height because even though I see the height is 12, I have two different bases. I have 18 yards, I have 10 yards for my bases, and that would lead to two different answers. So here's what I have to do instead. I need to break this up into shapes I can work with. I'm going to be looking for parallelograms and triangles. So first, I see I can make a nice triangle over here. So I have one triangle. Then if I look over here, I think if I draw a line down, I can make another triangle. So now I have three different shapes. I have two triangles and one rectangle, one parallelogram. So I know for my rectangle, I'm going to start there. All right, here's my rectangle. I'll call it R1 for rectangle 1. Well, I know to find the area of a rectangle, it's going to be area equals base times height for any parallelogram. So for this rectangle, I see the height's 12. I want to look for the base. The base can't be 18 because 18 down below goes all the way from one side of the triangle to the other. So I'm going to look up here and it looks like 10 is going to be my base of that rectangle. So my rectangle is going to be 10 times 12, which is 120 yards squared. So rectangle 1 is going to equal 120 yards squared. But I have these other two triangles to focus on now. Let me see if I can get a good color. Here's one triangle. That color is not good. Let me switch to pink. Much better. So there's one triangle, and here's the other triangle. So I need to figure out what those areas are. All right, so if I look at this triangle, it seems like they told me the base here from this part to this part is 4 yards, and the height is still going to be 12 right there. So I'm going to call that triangle 1. Now I need to remember the formula for a triangle. And please remember, there's only two formulas you have to remember: parallelograms and triangles. So the formula for a triangle, please remember, is area equals 1/2 base times height, or my favorite, area equals base times height and then divided by 2 to get half of it. Either of those work. That's my favorite. The one to the right is my favorite. So for triangle 1, let me move that. Okay, for triangle 1, I'm going to do base times height divided by 2, so the base is 4. Okay, so I apologize. I made a mistake before and I had to stop the video and start again. So the area for triangle 1, my triangle 1 is going to be 48 divided by 2, so the area for triangle number 1 is going to be 24. So now we have the second triangle. I'm going to clean this up a little bit. So our second triangle is right over here on the right. Now, it does not tell me a base and it does not tell me a height. But if I look, this height is the same size as that 12 right over there. So I'm going to say the height is 12. Now I need to figure out the base. I know from here all the way to the right is 18. This rectangle right here going up, we said the base was 10, so I could say it's 10 there. So I'm going to treat this almost like a tape diagram, and I need to figure out what that missing part is to get a total of 18. So I have 4 plus 10 plus something is going to equal 18. If I really want, I could put a variable there instead. This is going to be 14 plus something is going to be 18. And most of you can figure out that that's going to be 4, or I could do 18 minus 4, or 18 minus 14 to get that 4 as well. So the base is going to be 4. This triangle is the same size as our other triangle. So I'm going to say triangle 2 is going to equal, remember our formula, I like that one, or you could use that one. Base times height is 4 times 12 divided by 2. If we do that math again, triangle 2 is going to equal 24. Now that I have all three parts, I need to add that, and that to get the area of the entire trapezoid. So when I add those, 120 plus 24 plus another 24, that's going to equal 168. Our units are yards, so yards squared. So to find the area of a trapezoid, we break it up into rectangles and triangles. It's almost like a puzzle, and we're going to have to figure it out, but you really need to remember those two formulas, the ones for parallelograms and the ones for triangles. And then, at least in my Google Classroom, if you're on my team watching this, I will update, actually, I'll just put a sheet in there, so like a PDF or a picture of both formulas. All right, so let's try another one. Let's go back. Actually, let's do this one right here. A builder needs to cut stone in the shape of a trapezoid to fit in the space. What is the area of the front side of the stone? So here is the front side of the stone. First thing I'm going to do, I'm going to try to break it up into rectangles and triangles. So there's a triangle. I'll call that triangle 1. I could move that there. There's a rectangle. I'll call it rectangle 1. And then there's another triangle. I'll call it triangle 2. So let me start with triangle 1 over there. Remember, for triangles, the formula is area equals 1/2 base times height, or base times height divided by 2. For parallelograms, is just area equals base times height. So for that triangle, I see, if I look at that triangle, I see the base is 4 and the height is 5. So I'm going to say area equals, actually I'll call it triangle 1, equals 4 times 5 divided by 2. 4 times 5 is 20. 20 divided by 2 is 10. So triangle 1 is going to equal 20. I'm going to come back to that 20 inches squared. So I'm going to keep that because I'm going to need it. All right, so I'm done with triangle 1. Now I need to figure out this rectangle. If I see the rectangle, I see the top of it, the base is 6, and the height is 5. So I'm going to say, sorry about that. Let me switch to red. Rectangle 1, remember, area is just base times height for parallelograms. So for rectangle 1, it's going to equal 6 times 5, which is 30. So rectangle 1 will equal 30 inches squared. Now, here's the last part we need to do. We need to figure out that last triangle. Now, to do that, I need to figure out the base and the height. I know the height's going to be 5 because it's going to be the same as the other height. That's not going to change. So the height's going to be 5, but I need to figure out that base. So I'm going to draw a tape diagram. I'll split it up right there. I know that that part was 4. This part, if I look up top, it's 6. So I need to figure out what that is to get the whole thing to be 12. So 4 plus 6 plus something, is going to equal 12. So it's 10 plus something will equal 12. And most of you could figure out that that something is going to be 2. So I'm going to say, go back up there, erase. I'm going to say the base is 2. So now I'm going to have triangle 2. And triangle 2 is going to be, again, base times height divided by 2, or 1/2 base times height, whichever you prefer. So triangle 2 is going to be 2 times 5 divided by 2. And if I do that math, 2 times 5 is 10. 10 divided by 2 is 5. So triangle 2 will equal 5 inches squared. And now I need to add both my triangles and my rectangles all together. If I add all of those together, let me change colors one last time, of 30 plus 20 plus 5, and that gives me 55 inches squared. Okay, I'm actually not going to go back to the basketball problem for the sake of time. We have one last thing to talk about. It's a different shape, and this is called a kite. A kite has no parallel sides. So it says a kite is quadrilateral with 2 pairs of adjacent sides that are equal in length, but there's no parallel sides. If I look at this kite over to the left, right over there, I could break it up all into triangles. The original problem says Jackson has a rectangular piece of cloth that has an area 298 centimeters. Does Jackson have enough cloth to make the kite shown? I want to skip that. This is in page 401 of your book. I just want to go over how to find the area of the kite. We're going to break this up into triangles. When I look at this, I see 2 major triangles. I see one, let me get my highlighter. Right there. And I see another one right here. So those are my 2 triangles. I could really break it up into 4 triangles, but it's going to be way easier if I break it up into 2. So for that blue triangle, I want to figure out, let me get rid of the yellow for now. I want to figure out the base. And remember, for any triangle, it is going to be, my favorite is area equals base times height divided by 2. Again, you can do 1/2 base times height. So for that triangle, my base is going to be that 10 and 10 added together to get the whole thing from left to right, so it's going to be 20. So area equals 20 times the height is going to be 5 from there to there, times 5 divided by 2. 20 times 5 is 100. 100 divided by 2 is 50. So 50 centimeters squared is going to be that triangle 1. So now, let me clear that stuff up. I have that triangle right there. For this triangle, it looks like the base is still going to be 20, but now the height's going to be 25. So for triangle 2, we're going to have 20 is our base, 10 plus 10 is 20, times 25 divided by 2. If I do that math, I get 500 divided by 2. So the area of triangle 2 equals 250 centimeters squared. And now I add those two together. 250 centimeters squared plus 50. I get 300 centimeters squared. And that will be our final answer right there. So again, this is like a puzzle. You got to break it up into pieces. Decompose means to break it up. Break trapezoids and kites up into triangles, into rectangles, and you have to figure out the base and height of all. I know it's multiple steps. You have less problems usually given to you with these. Do your best. Look in your book. You have to remember triangle formula and rectangle formula, okay, or parallelogram formula. Once you have those memorized, you could find the area of any trapezoid and parallelogram. Do your best. I'll upload some other YouTube videos as well. There is a formula for trapezoids as well, but I think decomposing will be the least confusing way. Parallelograms and triangles. Always join my office hours if you need any help at all. You know, make sure you're using those formulas.